Welcome to Programming with Professor Califf. Today I want to show you the switch statement in Java. The switch statement is a more compact expression of certain kinds of linear nested if-elses. Let's start with an example nested if-else of the type that would work well as a switch statement. In this case, we have an int quiz grade that is a quiz score out of 10, and we're assigning the appropriate value to the character variable letter grade. So we have if quiz grade is greater than or equal to 9, so basically if it's 9 or 10, the letter grade will be A. Else, if quiz grade is 8, letter grade will be B. Else, if quiz grade is equal to 7, then we're going to set letter grade to C. Else, if quiz grade is equal to 6, we set letter grade to D. Else, letter grade is F. Let's see now what that would look like as a switch statement. So we're going to start with this keyword switch. And then in the parentheses, we have this variable quiz grade. Now you'll remember that with the if, that was the thing we were using, what we were comparing to in all of the different conditions. So then we have these cases. So what this means is if quiz grade is equal to 10, we're going to come here. If quiz grade is equal to 9, we're going to start here. Then we're going to do this code, setting the letter grade to A. Then we get to this break. That's going to drop us out of the switch statement down to the next thing after it. Just like with an if-else, once we've done what's in the if, we skip over the else and move on. Now, if quiz grade is equal to 8, we're going to go to this case, set letter grade to B, break. Same for 7. So in each of these cases, we're just comparing quiz grade to the value here after the keyword case, and then executing code after that until we get to the break. We finally have this default case. This is kind of like our else. So that says if quiz grade didn't match any of these other values, then we're going to come here and do whatever code is here and then fall out. You will see people who prefer to go ahead and have the break here. It's not technically required because we'll go ahead and fall out either way. So then let's look at the general structure of a switch statement. So we have the keyword switch, and then this expression in parentheses that will be what we're comparing the different case values to. Open curly braces, close curly braces, those are not optional here. Then we have our case and our first value, the code to do if the expression equals value 1, and a break. The next value, code that goes with that value, and then a break. And we continue to have cases and values in code and breaks until we get down to our default, which is technically optional. We don't have to have a default. But this is always the code to do if no other cases are matched. As you're writing switch statements, I do want to strongly recommend that you make sure that your case values follow a logical progression. It used to be very important that the case statements be in order numerically for efficiency, but compilers have gotten smarter, making that less necessary for that purpose. But we do want to remember that we are always writing code for two audiences, the computer, but also human beings. So we want to make sure that the order of our case values makes sense to any human beings who will read our code. In the structure of the switch, I showed a break after every case, but sometimes we leave them out. That can be because we want multiple values to result in the same code, as in our example. We had both case 10 and case 9 result in the A. This is basically creating an OR. So we're saying the equivalent of if quiz score equals 10 or quiz score equals 9. Note that we cannot say something equivalent to if quiz score is greater than or equal to 9. We have no way to express a range here. This use of no break is very common and very useful, where we have multiple cases without any code, and then the code at the bottom after the last of those cases that applies to all of those cases. We can also leave the breaks out after some code. This will result in doing all of the code for the case that matched, plus all code that follows until we get to either a break or the end of the switch. This is usually going to be an error. It's going to just have been a mistake. You accidentally left out the break. If you've got a switch and you're getting weird results, the culprit is often that missing break. Every once in a while, we will have a situation where leaving out the break after doing some code can be useful. But note that it's always at least a little confusing to read. So if you have one of those cases where you think it's a good idea, first talk to another programmer and get some feedback on whether this is really the right way to handle the situation. And then if you do choose to use it, make sure you have comments explaining what's going on so that the readers of your code won't be completely confused. One thing to realize as we look at whether or not to use a switch for something is that switches only work on certain data types. Those are int, which is of course what we were doing in the example, char, string, short, and byte. Note that long is not included. We cannot switch on a long in Java. For the strings, the matching is done using the equals method, so they are going to be case sensitive. There's no way to do a case insensitive match in Java in a switch. Note that if you are using a much older version of Java, the string won't work. Support for using string in switches was added later. Imagine that instead of a 10-point quiz, I want to determine the letter grade for a 100-point exam. Your immediate thought may be that switch is a poor choice for that because we can't express ranges of values. We have to have a case for every single value we're interested in. We could lump 59 and below together in the default case, but that will still leave 41 values, 600 to 100, that we have to account for. But I can solve this fairly easily if I remember two things. The switch can be done on an expression, not just a variable. The other thing is that integer division produces int results, assuming you started with ints. Taking this into account, I can solve my problem like this. So here we have our switch. And what I've done is taken my exam score and divided it by 10. So then if that exam score happens to be 100, we're going to match case 10. If it is somewhere between 90 and 99 inclusive, then the result of this integer division is going to be 9. So I'm just going to pop here. And so that covers all of my A cases. If it's between 80 and 89 inclusive, dividing by 10 is going to give me 8, which is where I want my B's. Same thing for 70 to 79 and 7, 60 to 69 and 6, and then of course all my other cases are wrapped up with my default. This is one of the reasons why we like integer division sometimes. Before I end this, I'd like to show you something in Eclipse. So what I have here is a program in which I've set up that same switch statement, or something very close to it actually, that we were looking at in the slide. The one on the slide was correct. This one's not quite. I've set up things so that the program is reading the score from the user so that we can try different things. And so let's first run this just to see what happens. So I'm going to enter the exam score. I'm going to enter 82, and I'm going to get a wrong answer. Now, I'm not going to get that in all cases. So if I run it and I put in 95, I'm actually going to get an A. But we do have a problem here, or we wouldn't be getting C for 82. So to show you what's going on and also introduce you a little bit to a tool that's very useful for finding these kinds of problems, I want to introduce you to the Eclipse debugger. And to do that, we're going to start by coming here and doing what's called setting a breakpoint. And so what I'm going to do is I can click on the 12 or on the little blue bar next to the 12. And I'm going to choose toggle breakpoint. And you'll see this little blue dot shows up right here. And the pop-up says line breakpoint switch example line 12 in main. So this is telling me this is a breakpoint and here's where it is. So now that I've done that, instead of running my program the way we've typically done, I'm going to do what's called debugging the program. So instead of clicking on run, I'm going to move over here to the little bug and debug. Note that if I do the right click down here, I'll find a debug as, just like the run as. If I check the run menu, there's run or debug, run as or debug as. So we'll make it start. Initially, this is just going to start the program like it always starts the program, and it'll run until it hits that breakpoint that I just set. So let's put in an exam score. Go ahead and do that 82 again, because we want to see what the problem is. And at this point, it's going to ask me if I want to switch to the debug perspective. So right now, if we look up in the corner, we have this blue button that has the J, and that's called the Java perspective. That's where we're usually living these days. So this is asking me if I want to switch to a perspective that's set up for using the debugger. And so I do. In fact, there is almost no occasion where this might happen when you don't want to switch. So when you're doing this yourself, you might want to click on the little checkbox here that says remember my decision. So we will switch, and you'll notice that up in the corner we've switched from the blue being the one with the J to it being the one with the little picture of the bug, just like what we used to run the program. So what we have here, we have a panel over to the left that we won't worry about too much right now, though we'll find it very useful later. It shows us where in our program we are. We don't have a lot of places to be yet, so we're in main. Here we have the source code, just as we had it before, except one thing is different, and that is that this line, line 12, where our breakpoint was, is currently shaded in green. And what that means is this is the next line that the program is going to execute. So when we hit that breakpoint, we switched into the debug mode, but more importantly, we paused our program. And so we can go through it step by step and watch what's going on. Here's the console. This is just like it normally is. Over here to the right, we have variables. So right here, you'll see that we have this exam score and it is 82, just like I just read into it. So there's nothing wrong with what the exam score is getting. Okay, so let's start stepping through. If we look here, we've got some new controls. The ones we'll care about, resume just means start running the program and keep going until you get to another breakpoint or the end. The pause or suspend that has the pause button is basically the stop the program running right now. What looks like a stop button is terminate the program. We won't worry too much about the disconnect. It doesn't apply to anything we're going to do. Then we have a step into, which we will again look at later in the series. The step over is what we're going to want to use. This lets us go one step at a time, but if we get to something where we're running a function or method, we're going to step on through that, just do that in one lump. Since we're not writing those ourselves, that's exactly what we want to do. Let's go ahead and choose step over. And you'll notice that after this line executes, we now have the letter grade. We can't see the value very well because it's a space, but we have it. Now at this point, we can also check to see what exam score. So here I can see variables. I also have a thing where I can have expressions. So I'm going to actually add a new expression and say exam score divided by 10. And that will actually show me what that value is. So I can see for sure that the value that I'm switching on should be 8. We'll go back to our variables for right now. But this is great. If there's something that's not a variable that you want to see what the value of it is, you can just add another expression and see what that is. Okay, so let's keep going. We're at the switch, and the value of exam score divided by 10 was 8, as we saw. So we jumped to case 8. and we have the letter grade as B selected. So if we step again, we'll see that the letter grade does become B as we would expect. But we've just discovered we don't have the break here. So the next thing that will happen is the letter grade C will happen. Then we get to the break. When the break is executed, we're going to jump out of the switch and do our print. Now, I'm going to run this again to show the different behavior. So if I debug it, which I can do from right here, don't have to go back to the Java perspective to run things. And I'm going to do it with 93. So in that case, we're going to stop in the same spot with the different value. If we go look at our expression, it's still there. We can see that it's 9 this time. We step, the switch executes, sending us to the appropriate case. We get to the letter grade as A, so that gets set. We do the break, and we jump to the print and on out. Now, to fix this, of course, we're just going to put in this break here. And then we can run it again and watch it work correctly. Now I'm going to actually not, well, we will step through. So we do the switch, we get to the letter grade as B. We have the break this time, so we jump on out and print the B that we were supposed to be printing. The debugger is really useful for watching what happens. It's a great tool for finding bugs. It's also a great tool for just learning what's going on. So as we move on and we start to look at things like loops, I really encourage you as you're playing with code to just come over, set a breakpoint before the loop, and walk through and watch what's happening with your loop. In case you're wondering why you want to use switches, even though a linear nested if-else can always be anywhere a switch could be used, here are the main reasons. It can be more compact, just less typing if the problem is well suited to a switch. Most programmers would consider a switch easier to read as long as the problem is well suited to the switch. And switches are typically a little more efficient in execution than the equivalent nested if statement. That's usually not anything that you're going to notice, but sometimes it does matter. So I encourage you to work on learning about the switches, practicing using them, and to think about what problems a switch is a good fit for. Thanks for watching. In the next video, I'll introduce the while loop, which is the most versatile of the control structures we have for repeating code in Java.